All right, let's get this party started. We are going to talk about comparing data and what it means to have skewed data. So again, if you haven't printed the notes already, I would pause for a moment, print those out so that way you don't have to be writing all this down. I've pre-written a lot of it. We'll fill in a few things here and then you can make some notes in the margins and then you will have a complete set of notes. All right, so how does skew in data affect the relationship between mean and median? And you're going to see questions today on your Pearson assignment asking just that. Like when you have a right skewed set of data, what does that mean in terms of the mean and the median? So skew, definition-wise, is data that is not uniformly distributed. So we talked about that perfect hill, that mountain of data. Well, not everything is nice and perfect and normally distributed or uniformly distributed. So that means that there's going to be some skew to data. So when that happens, it's saying that we're actually pulling data to one side or another. And it's very visual when you have a data display. So if we looked at these two data displays here, so the green one, the dot plot, we can see that there is, like we like to call it a tail, right? So the data is being pulled to the left. So when you look at your data, you can look at it sort of as where is the slow building slope, right? Or where is the tail of the data? And it is on the left side. So that means that this particular set of data has a leftward skew. So we'll call that a left skew. And when you have a left skew, that means that your mean, so your average, is also being pulled to the left, right? So it's actually taking the values and it's pulling them, so it's pulling your average value down and to the left. So that means that your middle value usually stays kind of where the big clump of data is. So median will be somewhere about here and your mean will be somewhere about here. So that means that your mean is going to be smaller than your median when you have a leftward skew. So you want to know that, you want to write that down. So your mean is going to be less than your median in this case. And that is because those smaller pieces of data are pulling your average value, your mean. So think of it like test scores. If these were low, like failure scores, and then we had a lot of people get, A's and B's, the average is going to be pulled a little bit lower because of these lower scores here. So the average might actually be maybe like a 75%. But the median, the middle score, is going to be closer to where the bigger clump of data is, of course, because you're literally counting to the middle. So that's why your median will be greater than your mean when you have a left skew. So here's another data display over here. In this one, we have a box plot. So this box plot, notice you have a long whisker right here, and you also know that your median is, everything here is being pulled to the right. So your tail, again, is a right, being pulled to the right side. So this is going to be a right skew. Okay, when that happens, what do you think happens with your mean and your median? Well, they should switch places, right? Your mean is now going to be bigger than your median, meaning your average value should be greater than your middle value. So in that case, we switch our sign. The mean is greater than the median. Okay, so remember what that means then, and you should be able to put this in terms that you can, rephrase if we were to ask you to describe a skew. So when the tail pulls the mean with it, that means the median is staying closer to the larger grouping of data. So whichever way your skew is, that's going to be the side that your mean is going to be pulled towards. Your average is going to be pulled towards. So we're going to do one example together, and then you're going to be done with notes today. So using the data below, we're going to find the mean, the 5-number summary, we're going to create a box plot, and then identify any skew. So you can see we're going to cover a lot in just one quick, easy example. So these are the data points right here. They're already in order for us, from 27 all the way up to 62. So when we talk about mean, we're talking about average. And hopefully you remember how to find that. If not, what we do is we add up every single number, then we divide by the number of pieces of data that we have. So rather than me waste time on the video, I went ahead and did it ahead of time. So I'd like you to pause it here if you want to calculate it yourself. So pause the video, add your numbers up, and divide by the number of pieces of data. When you do that, you'll get your mean. Now the median, or quartile 2, Q2, median, middle, right? Those all are interchangeable. We literally find our way to the middle of our data. And in this case, once again, we have two middle values. So we have to add them together and divide by 2 in order to get the actual median. So 41 plus 42 gives us 83, and you divide that by 2 and you get 41.5. So that will be our median. Then, because we know our Q1 is right here between the 41 and 42, sorry, that's our Q2. Our median is right here. That means Q1 is going to be the middle value in between, the middle value of our left side of our data. So we go just to the left of Q2, so that includes 41 there, and then you find the middle value, which again is, let me see, I think I did one too many. Yep, okay, so it's actually 31. That right there is the Q1 value. And then for Q3, we do the same thing just to the right of Q2. We take 42 to 62, we find the middle value, and it happens to be 46. All right, and then minimum and maximum, 27 and 62. All right, so I'm going to go ahead and show you all the numbers that we just talked about, because like I said, I calculated them already. So if you got a 40.7 for your mean, good job. That means you added them all together and you divided by the number of pieces of data. So we have found our mean and our 5-number summary. Now we need to discuss skew. Now you can discuss skew without getting a visual, because we know how skew is related, or how skew is affected by the mean and median relationship. So just looking at the mean and the median, in our case, the mean is 40.7 and the median is 41.5. That means the mean is smaller than the median, so we should have a left skewed set of data. When we actually graph it here, we should notice there's going to be a longer tail on the left side. But let's verify that. So let's go ahead and plot all the values we need for our box plot. So in order to graph our box plot, we want to put a dot at all 5 of these values. So our minimum is 27. So obviously I'm going by 5s on my number chart, so I have to kind of guess where 27 is slightly. Maximum is 62. Q1 is 31. Q3 is 46. And our median, Q2, is 41.5. So we put a box through Q1 and Q3. Then we take the median and draw a line through that. And then we connect, oh, and look at this, actually. So we have to be careful with this data, with the tail. We can't always look at the whisker as our tail. What I need you to look at here is the grouping of data from the median to the left. This distance here, let me use a different color. This distance here is going to be greater than this distance here. And so that's how we can tell that there is a slight skew. Now the skew is actually very slight, and so because you can see how close our mean and median really are. It's much more clear with a data picture when you have a bigger gap between your mean and your median. So it's good that we actually had the math to back up which way our skew is. And if you look at the data, you can see that you have a big grouping of numbers in the 40s and 50s. And that right there is kind of your big chunk of data, like what you see up here. That's your big grouping of values. And then you've got these values here that are pulling your average to the left. So that's why our mean is smaller than our median. So that's interesting that our box plot did not give us quite as clear a picture, but at least we have our values to back it up. All right, so you are now ready for your Pearson assignment. So that'll be assignment number 2, and I will have that in your Pearson account when you log in. Good luck, guys. Let me know if you need anything.